What we're going to do today that is correct is look through media and entertainment as a vertical. What are the different kinds of applications? What are the solutions, systems, the designs of physical infrastructure, software, and services that help people use and deliver media to customers? We'll go through some of those examples in more detail around storage, around processing, and then distribution technologies. We have solutions in all of those areas. And then a couple of quick notes on how to get started. So what I'm talking about when I say storage, what are the use cases in media that fit into that context? So archiving data, making sure that once it's out of rotation, you've got that stored long-term. Storage in each of the different processing steps, from first capture to transcoding and encoding, to streaming or non-streaming live delivery, and then all of the processing steps. What's the compute that gets used? What are the application software there? And then further from that, distribution, publication of the content out to the edge. What are the client software tiers? What are the different services that you use to deliver this stuff out to the edge? From what I've seen working together with some of our biggest media partners, there's a pretty significant shift in the market around media delivery. Certainly, I think it's been a couple of years that it's been digital first, where the content starts in a digital format and gets delivered into potentially downstream analog versions for playback in major film houses. But by and large, the editing and processing steps are being done in a digital way. So the bar has been raised. It's kind of a given thing. Everyone watches video on these, and they want to make it so that their video can be watched on these. And they've got most of our customers have a very high expectation for what's possible. So we know that means scalability. It means the ability to deliver early and fast and cheap and quickly. We also know that it means you have to be able to support all the different kinds of complex business models, whether that's pay-per-view or pay for time or subscriptions to content. And we know that the media landscape has different kinds of performance characteristics, different requirements than standard web applications or gaming applications or high-performance computing, other sorts of verticals. So we want to make sure that we're building systems that help get after that complex and challenging landscape. There are a lot of different building blocks that get used. You have to have the sort of compute infrastructure to do this. You're not watching video anymore at 640 by 480. This is high def. Some of it's high def in 3D. Some of it's high def in 4K at 3D. You're talking terabyte mezzanine files, very, very large content. And then all of the same processing that everyone wanted to do at lower resolution video, they still want to do at higher resolution video without realizing that's significantly more expensive to do in most cases. So we're trying to drive those costs back down to deliver services that make it so that it's cheaper to bring that kind of content to market. We know that a whole bunch of the basic work, similar to several other verticals, is the same. Every time you rack and stack another computer, it's exactly the same as last time. There's no differentiation between you doing it and one of your competitors doing it. There isn't anyone out there that's so much better at doing that they're able to earn a competitive advantage there. And you have sort of a set of expertise that only gets less and less valuable over time. So we're trying to help alleviate that pain. We are going to go do the work at Amazon Web Services that is undifferentiated heavy lifting, that's consistently redone, and help reduce your price and time to market for those kinds of services. So what that means on our side is elastic deployments, very, very rapid time to value. Servers start in minutes, and pricing for exactly what you use. So to get into maybe a little more detail of how that works, these five sort of major differentiators, places where because of massive scale, because of the ability to move data very rapidly, because of significantly lower cost, higher reliability from an infrastructure standpoint, and a very, very, very sophisticated security topology, we think we have some solutions that help people bring media services to market in ways that are difficult, if not impossible, in other environments. So I work together significantly with Netflix. Netflix has built a number of different services on us. There are plenty of examples. This one specifically, they have a very large media library. They have titles of video, and they want to be able to deliver that in every format that's available. When the PlayStation 3 launched, it represented a new format. The video now needs to be transcoded into a format that can play on PlayStations. But Sony's not going to give the data out about exactly what that format looks like until the very last minute, because they're in a software development mode. They're in the middle of finalizing the design for that. So the time window to do that transformation of video into the new format shrinks and shrinks and shrinks. The opportunity there is to have all of the video there available right at launch time for the console. But if you have less and less time to do it, some part of that graph has to get taller and taller. So they use a very, very significant stack of compute infrastructure on our side, but they used it for a very short period of time. So these spikes where you're looking at the red lines at the top, that's bursts of content encoding, 80 terabytes of data being transformed into 17 distinct formats, and then now the 17th being video playback for PlayStation 3. They were able to do that in days instead of in weeks or months, and to do that with little to no notice to us. We don't really need that kind of lead time. We have plenty of capacity to be able to do that kind of work. Another example in the gaming space, Playfish worked with us to build an online platform for gaming. So it's not just that they've written a game and then they hand out the CD. Now games are services. Games are web applications. Games need a full back-end stack to be able to perform the computation required to keep your high scores and deliver the next, the little cutscene in between the videos. All of that content really has to be replayed to each of the individual players, and success is measured in the number of folks playing your game. So these all end up, if they're successful, being very, 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 very big infrastructures. So they worked with us to deal with, like it says, 4 million players in 8 weeks. That's a pretty significant growth curve. So those are just general scale examples. To get into the specifics of the tools that get used, we have 3 major products for storage or storage facilitation. S3 is the global storage in the cloud. It's a system for storing content in a very, very high durability, very high availability way. It's an object storage system, so rather than a POSIX file store like a hard drive in your computer where you can change the contents of individual files, in S3 you store whole objects in their entirety, and if you want to change them, you store a whole other one. The advantage of that is that there's no outer bound to the maximum scale of S3. I think we talked, or Werner spoke earlier about we're up over now 900 billion objects stored in S3. We work together with customers that it's very normal to store petabytes and petabytes of data in this environment. So, and to do so at pretty exceptionally low cost. So S3 storage is honed in each of the regions. So there are 7 regions today. Each of those regions has their own distributed store of data. That store is exclusive to the region. So data does not move from region to region unless you tell us to do that. There's no sort of global replication of that content. Make sure that you have clear control over where your data is stored. EBS is kind of the opposite. EBS, you're renting disk storage from us. So EBS attaches POSIX compliant, full sort of normal hard drives to EC2 instances, compute that you rent from us by the hour. That allows you to have temporary storage or processing storage as you're doing work that is persistent. So if you need to turn down, stop all of the machines in a compute fleet, EBS will store your data long-term so that you can bring that compute fleet back up to do the work like transcoding or encoding video, serving that video out to customers. We've added some new features to the entire network subsystem, one of them being Direct Connect, where you can make very, very low latency, very high performance connections into the Amazon Web Services footprint. So Direct Connect allows 1 gig, 10 gig, multiple 10 gigs. You're typically in the low single-digit millisecond latencies from the AWS physical footprint. That allows you to do a couple of different things. One, you can move data into us very rapidly, move data out of us very rapidly. You can co-locate dedicated, purpose-built, specific sort of compute infrastructure right next door, next to our data centers. Makes it very, very easy to build the full stack of infrastructure required to serve media. So lots and lots of customers obviously doing these kinds of things. Some of the biggest users of storage, frankly, in the world are building on top of us rather than going and doing this work on their own. From an architecture standpoint, so S3 is the big box at the top, and then a pattern that we're seeing a lot more customers start to use. S3 because of its infinite scale. It's very, very normal to have customers that have folders, or buckets as they're called on S3, with hundreds of millions, with billions of objects in them, the chunks of video streams, or the individual pictures, or JS files, or CSS files, objects from websites. So because so much content can be stored in S3, the metadata about that content all by itself is a very large set of data. So it's important, if you want to be able to query and analyze the metadata about your storage, to store that someplace independent of S3. S3 is just object storage. It doesn't have any of those behaviors. So just like if you had a hard drive that was 50 petabytes in size, you would probably want to store information about that hard drive someplace else than on it. We have a lot of patterns where you'll use either relational database systems. We have a service called RDS that makes it easy to deploy MySQL or Oracle or now SQL Server in a managed way on EC2, or you can use our NoSQL systems like SimpleDB or DynamoDB that are patterns for storing the metadata of storage outside of the primary store. But what that gets you to also, you can see there are multiple sets in parallel interacting with S3. An individual transfer in and out of S3 is very high performance, is a system designed to move large single-digit megabytes a second in and out of an individual thread. But there's no outer maximum to the scale of S3 as a system. So it's important that you interact with it in a multi-threaded way. So lots of customers build together with software that a lot of our partners have developed, systems for moving in parallel thousands of files at a time back and forth. That allows you to take advantage of multiple different compute nodes on our side and accelerate the throughput. So there are a lot of different tools that do that. Aspero is a popular one. Cloudberry Pro works very well for Windows users. Riverbed Whitewater makes an appliance out of this. Symantec Net Backup now can make direct copies of content into S3. Database systems are all being added to this list as well. Oracle's RMAN does this. So rather than individually interacting either with our API or with our management console for each one of the files, you can use a piece of software like this to move all the data that you want, to build a workflow around moving data in and out of the cloud, in and out of the media systems that you use. EC2 is a compute resource next to S3. It's right next door. So that network between those two is very, very high performance. The example here from Aspero is from EC2 instances writing directly into S3. You can have as many of those machines as you need. So that 700 meg number can go right up through the roof if you want. We also have our own service for this. So this is really useful for folks that have big NFS mounts in your office, maybe a DAS system or a small NAS system. You run a virtual machine on premise. You install that as a shim in between your current servers and your storage. Every object that gets written down to your storage, your local storage, also gets replicated to S3 automatically. We just take care of it. So that enables or facilitates two very different, very useful workflows. So one, if you lose your local disk, you can go buy another local disk and download it back from the cloud. Your data won't be lost. We'll take care of that. But also, that data is stored in S3 as EBS snapshots, as backups of EBS drives in that format. So you can start EC2 computers, hook those EBS drives up, and all of a sudden you have access to your data in minutes rather than hours for downloading it from the web. So very, very rapid access to content if that's a part of your disaster recovery or high availability design. There are several of our partners that were here at the conference. There are hundreds of businesses, thousands of businesses that are building themselves on top of this infrastructure. That has a couple of benefits. It's not just that they work well with us. They're actually physically in our data centers. Their software is running on the computers next to the computers that you can rent. So with ZenCoder, if you want to do online encoding of video content, you can store that software, that data, the data for your videos anywhere. You can put that in a data center here. You can put it in somebody's back office. We really don't care. For ZenCoder to do the transcoding work, they have to bring it into their network. That network happens to be our network. So if you store that data in S3 instead, it takes seconds to do that work. You're right next door to your partners. You're milliseconds away from them instead of hundreds of miles or thousands of miles. So for ZenCoder, when they do transcoding, that's 80 times faster for them on average if you're already in S3. Big benefit for having your content in the sort of now hub for this kind of work. So that kind of work is processing. We have a whole bunch of different systems for helping people build scalable infrastructures for the compute side of this. One is just the compute itself, EC2. When you rent computers from us by the hour, they're high performance, they're secure, they're really designed to serve all of the different application workloads that you're thinking of. You can run Windows machines, Linux machines, all of the different content servers, and there are several different application platforms that we'll talk through here in a bit that run on EC2. Basically anything that runs on x86 at this point, barring a couple of sort of very far outside examples, all that software runs really well with us. But if you don't have software yet, or if you're in the middle of building a new pipeline, building a new workflow for media, really would strongly suggest using Elastic MapReduce. That's our Hadoop environment. It allows, is used very frequently. You'll hear Werner and the others talk for big data analysis, but it's also really a convenient tool for multiple machine management, just for coordinating the action of suites of systems doing this kind of processing work. We have lots of folks that are writing their Java applications to run inside the Hadoop framework so that they can take advantage of all of that job management from EMR. We also have just added GPGPU instances, so instances that have high-end video cards that allow accelerated transcoding. I'll show some examples of that. So for batch processing, like I just talked about with EMR, from a topology standpoint, most of this stuff, you will have a user interface of some kind, some application server that you log into that has pointy-clicky things. There's a website that you'll go to or a web app layer where you're interacting with the transcoding software or the serving software. That stuff sits pretty close to your user, pretty close to the edge of the system. But as you go further into the architecture, you'll be accessing data that's stored in S3, accessing metadata and analytics information in relational databases or NoSQL databases, pretty similar to the upload structure we talked about before. But the stuff on the right, an auto-scaling queue of worker nodes doing your transcoding, doing your processing work, only on when you need them, off when you don't, only being paid for when they're on. Pretty powerful architecture. We also see these kinds of topologies being wrapped in code. So that's a whole part of all of this. Every single part of the Amazon Web Services infrastructure, plenty of them that there aren't buttons for, frankly, are available by API. So all of this stuff can be scripted, can be coded, can be automated. We have that available in a half dozen different languages at this point. So your developers have an interface to build these kinds of scalable systems. What that looks like for folks that are building new stuff, and Emoto works with us, they build a really cool tool. You send them pictures, video clips, songs that you like, and they just sort of mash together like a home video that's cooler than you and I can make. It's got fun-looking transitions, and the music times right, and it sort of shows all the best parts of your content. You don't have to be a videographer or a video editor, it just works. But it also works on their side. It takes a lot of compute to do that kind of analysis, to figure out what the good content is, and then also to do the sort of transcribing of that into new videos. For us, we see these kinds of curves pretty frequently, but they went from 50 to 50 or 5,000 servers in just 3 days. So that was driven by a Facebook application launch. So sometimes this stuff isn't really intentional. You're trying to build a business, you're trying to grow as quickly as you can, you get some notoriety or some coverage that you didn't expect, and zip, there, that curve upward is an opportunity. You can either meet it or not. So they did a great job with us, but this is just the sort of normal processing of the application. They were able to extend that with GPGPU. I'll show that in a bit. So for Animoto and from others, this is a curve I think you guys will see very frequently. I know when you're going through to do new application development, new application design, you have to make choices. We're all folks, when will we buy the stuff that we're going to use for our infrastructure? So that happens at individual choice moments when you're building something on an API, when your software makes the choice as to when it is the computer should turn on or off. You get to do that right when you need it. So the difference between when you and I would pick, hold on, I got to get a sales guy, he's got to come out, I'm going to have him ship our stuff to us, we got to get it racked, we got to get it stacked, and the software installed. Those gaps in time are their opportunity cost. They're opportunities lost potentially, and sometimes that doesn't happen fast enough for the opportunities that you have. So Vimeo, they're another video transcoding customer of ours. I think they said it really well. They're trying to describe that customers don't actually care what the infrastructure behind these services are. They just want to watch their movie. So it doesn't really matter how it is that the sort of back end is established. They're not choosing a video provider based on how much they trust the back end. They just want it cheap, and they want it fast, and they want to have it right away, and they want a great experience. So for Vimeo, they took advantage not only of the on-demand pricing, but they're really heavy users of Spot. So we have a whole separate system for pricing called Spot, where instead of paying the on-demand rate, if we have any servers that are unused, we'll sell those to you by the hour at a reduced rate based on actual market demand. That can be up to 2/3 off the top of the price for some of these machines. The flip side of that is if we have folks that come on and want to pay full price, we'll give them your computers. So you need to do some architecture work to be able to survive those kinds of transitions. But Vimeo's made that software investment. It's really allowed them to cut the bottom out of their pricing. So for their free customers, they use Spot instances. They can tell those customers, they can set expectations with them, look, we're not going to transcode your videos fast. We're using a lower cost service to keep our costs down so we can have this be a free service to you. For their premium customers, for the ones that have already paid, they use reserve instances. They pay up front to ensure that their customers have a great experience and to save money over time because they know exactly how long those customers are going to be there. They have a clear subscription from them so they can plan ahead and save money. So Animoto, it's kind of out of order, but it's okay. Animoto did used to do all of this at 640 by 480. Used to do this on kind of old school video and web video. They were delivering that content very frequently, but they heard from customers over and over and over again that they wanted this done high def. They wanted to be able to show it on their big screens at home, not just their laptops, but their friends. So they switched on us from doing most of this processing in standard computers, standalone CPU-based machines, to using CUDA, which is a programming framework from NVIDIA, to take advantage of GPU boards inside of our instances. We use a pair of NVIDIA Tesla 2050s. That works out roughly to 1,000 cores in those machines instead of 8. So that's a little faster, just a little bit of a benefit from a performance standpoint. For Animoto, that was 10 times faster through their entire workload. And it gets done at twice the resolution, squared really, go all the way up to 1080p, and it costs them less. It's cheaper for them to deliver their new product than it was to deliver the old product at 640 by 480, and customers like it better. They actually cut the bottom out of their pricing by using this system. So very powerful change in the way that this work is being done. You've heard of the rendering farms that work the same way, the Weta Digitals and the guys at Pixar. All of those teams are starting to look at and are taking advantage of GPU. So we've democratized that. You can rent just one of these computers. I mean, to buy these cards, I mean, they're like $10,000 in hardware. You rent them from us for, I think it's $2.10 an hour. It's just crazy. So to distribute that content, once you've got it into the format that you want, we have a couple of other services that we built. So CloudFront, very powerful service. That's our CDN. It's a system for distributing content to the edge. We're going to talk through a couple of different details of that. We've also built Route 53, that's our DNS service. So Route 53, together with CloudFront, together with our load balancers, elastic load balancers in EC2, builds a very high performance distributed architecture for delivering media. And we'll talk through a couple of examples of that. In most distribution systems, you're still going to have some computer in the back that's actually running the origin or has the original copy. Something's got to answer the question, where is the core video? It's just that you need all the rest of these services to be able to amplify and extend and reduce latency for customers. So CloudFront in a nutshell, very high performance CDN, also hilariously low cost. Unbelievably cheap in comparison to most ways of doing this. There's no upfront. You pay for exactly what it is that you use, and there's no push. So when you typically use the CDN, there are a bunch of others that are out there, you take the content that you want and you publish it to the edge. You say, I want this content and I want it over there, and you push. And when you do that, you're paying for it being over there for every second that it's there. You can get that in sort of big subscriptions and blocks of usage. But with CloudFront, it's different. It's a pull. So I'll show you what this looks like. Normally, when you have non-cached video, and you're using CloudFront, first the edge request comes in. A customer wants to access the video. That'll come to our servers at CloudFront. CloudFront will check its cache of content for that URL and say, I don't have that one yet. Okay, I'm going to go back to the origin, go back to the original copy of that machine. Now, the origin can be S3. That's pretty typical. Folks keep video in S3 because it's very, very high scale, very, very high availability, really designed to be able to serve a very large number of data sets, and it means you don't need to run any servers. So if S3 in US East base price is 12.5 cents a gigabyte, the smallest servers are 2 cents an hour. So it's a lot cheaper to run storage than it is to run compute. So, but we have some applications where you need dynamic construction of video content. You have your own sort of media servers for DRM or authentication. Fine, you can use computers to run that. It doesn't really matter what the origin is. You can use S3 or EC2 or a computer someplace else. We don't care where it is. Once that content is fetched from the origin, it's stored in the cache and then served from the cache to the customer. That means the TCP window to and from them is consistent. It means it comes from a local edge. It's very, very low latency in comparison to the fetch from the origin. And typically that means that the user enjoys their video. Now, once it's been copied to the edge, it stays there. So we have variable timeout. You set the TTL for objects. If no one's come and looked at a piece of video in weeks and weeks, we'll get it out of the cache. That reduces the cost of delivery of the cache automatically. There's nothing you have to do on your side. You don't have to tune any of this or configure it. You just say, cache this bucket, or cache this server, or cache these URLs. We take care of that stuff. If it's in cache, it just gets served from the edge. You save all of those upstream links, and down it comes. We have customers that have an SLA with their customers. They want to ensure every single time it gets loaded. So it's all backwards. You end up querying us programmatically once a day to ensure content is in the cache, instead of pushing and just expecting to sort of pay as a result. So from an architecture standpoint, we have a lot of this that gets run, again, with S3 as an origin, but it doesn't have to be. You can use your own private servers. You can use EC2 machines of all the different sizes. You can also live stream to CloudFront. So works fine with RTMP streaming, works fine with smooth streaming from Windows Media. All those different formats are good. You can run that through into CloudFront and run that out to your edge server. We run Adobe FMS 4.5 at the edge. We run Windows IIS 4.1 media streaming at the edge, so you can connect to those customers at high performance. We've also just announced, this is the joy of agile PowerPoint decking. We launched this service 2 days ago. So welcome to the future of CloudFront. It's here today. CloudFront works now for dynamic content. So not just the static stuff like video or live stream or those kinds of pieces. You can run in a query string and dynamically get whatever you need from your edge and have that cached. So if you have one URL, but based on the user cookie or this other metadata your application wants to serve a different picture, fine, we'll take that back from the edge. It also means, really slick, one distribution can have all sorts of different rules, all sorts of different kinds of content. So instead of passing a whole bunch of different DNS entries down to your customer, having a sort of more complicated experience where there's 20 or 30 different distributions for the different kinds of content you have, you just have one DNS entry on your site, one DNS entry for their application to cache, one DNS entry for their end ISP to cache, so they don't have as many lookups, much faster performance. We also hold the TCP window open now for a full 10 instead of 2. Makes it a lot quicker to do the high throughput delivery of video and other kinds of high density content. So we'll also allow you to do signed and unsigned content. So you could have like the pictures and the CSS files, the Chrome for your website. That could be unprotected, could be unsigned content. Accelerates the performance of that, lowers the cost of delivery of that. You could have other content that's signed, that's highly protected, your video content, the sort of crown jewels. You can have that all in the same distribution now, really a slick way to do it. You also can just use CloudFront as an optimized routing system. So you can set all of the TTLs to 0. We won't cache anything. We'll always go back to the origin, but we'll route it through our optimized network. It makes it faster to get it out to your customers. So PBS, that's the public broadcasting system. They do Sesame Street and all the really great kids content in the United States. Lots of historical content and other sorts of stuff. They're moving a petabyte a month through CloudFront. And that's, they do that with not the biggest team you've ever met. So this is totally doable on public funds, on a shoestring budget. You can put this kind of thing together. They sort of turn on the CloudFront distribution and put their edge cache up, and every kid in the United States wants to watch those Sesame Street videos, and out goes the video. So they've reduced their investment in technical depth and their investment in building these kinds of services. They just turn them on, make sure that it works, and it goes. So we're continuing to grow global footprint. I know this is an open question. Everybody wants to see this slide. Right now, what we're built is CloudFront locations in 30 different places around the globe. We have regions in 8 different locations around the globe. We'll continue to add to that over time. That's our goal, is to be everywhere as quickly as possible. That's just what we're intending to do. Next slide. Media and entertainment customers from the CDN need to be able to guarantee good experience to their customers. Need to prove that. Need to be able to measure it. So Amazon built our business on measurement of performance. We wanted to make sure that it's not just that we say that it's pretty good, we want to go and do tests for that. So we partnered with probably the biggest of the test groups, Gomez. They run out of the United States. They have their own group of last mile users, so they sign people up and pay them to be validators for the performance of video content. There are a lot of different ways to do these tests, but we're seeing a lot of competitors build this, what we call sort of first mile tests. So data center to data center, how fast is their network? Data center to first edge, how fast is their network? All this testing is done with remote, local, distant, guys at their house, girls in the backyard, folks with their mobile phones, remote devices. And what we're found in several tests, this one specifically from Japan, but that we're at least at par. Many times we're better than, most of the time we're at least as good as, and we're hilariously cheaper in comparison. So we're happy to take the Pepsi challenge. We want to make sure that we're ready to go on pricing. You'll see in our pricing pages that we charge at a tiered rate. So the more content that you move, the less it costs. But if you get sort of further down in here, there's parts where it says, contact us. We're happy to have a conversation about what it is that you think is the right price for this stuff at scale. This is one of the places where we're eager to earn business, and a place where we think we're very, very competitive. So we also know it's totally critical to deliver this content to a huge variety. Like, it's not okay if you're going to build a web serving system for video and have there be some customers you can't get video to. It just doesn't work. Most of the time, the reason that you don't go do that is that the technical complexity to the delivery of all those different devices is relatively high, that the sophistication required to build an infrastructure that can deal with right now, it's typically 18 different transcoded formats, independent of the number of different bit rates you deliver to for performance. That can be a real pain. What we believe is when we built this system up, we've made it so that you can invest on that side, on the technical sophistication of the delivery and ensuring coverage, making sure that you've got a stack that you understand, and maybe reduce investment in the amount of work required to make sure that the machines stay on and that you've got everything racked and stacked. So another example from a scale standpoint, we work together with a bunch of different customers. This is one of those places where most of the time these charts, they just stay like this. Folks have a relatively predictable performance load. They have in-house workloads. This happened to be an example where folks had video that was inside the building, and then a boss decided, this is a great video. We got to get this out to the world. This is good stuff. And made one of the internal engineers turn something public. So all of a sudden that line goes straight up. When you do this in places that can't scale like this, the line goes up for a little bit, and then it goes down, and it stays down until somebody gets a page, and then it goes up again, and it starts working. So we're trying to make it so that you survive those spikes, that you can make it through those kinds of workloads. This, again, is a peak at over 60 gigs a second, where nobody told us. There's no, phone call like, hey, 60 gigs going to be okay? Can we pay ahead for that contract? We don't get any of that. It's just designed to scale to those kinds of magnitudes. So we also know, totally critically, that this content is worth money. People pay to see video. That's the whole point of filming it in the first place most of the time. So unless it's the YouTube videos of guys like dancing and doing silly faces and making strange cat jokes. So we think that most systems sort of get started, and when they're building in the right way, they're thinking security first. We want to make sure that they have that box checked before they go anywhere. So we're really serious about security here too. Amazon really did all of the, some of the biggest first investments in making it so that there's a secure purchase environment online. So we take a lot of benefit from that expertise. We have folks that are very senior in this environment. I think Steve Schmidt did a great job earlier talking at a high level about how Amazon is secured. But media can be secured in the same way. So we're compatible with RTMP streaming. We have SSL at all the different edge points. You can do it completely encrypted. You don't ever have to show us the keys for the content that's stored. You can have all of the encryption stuff located someplace else. All of those models make sense. You also have a whole set of sophisticated tools from us for securing content. So maybe you need to have the content in S3 encrypted, but you don't have the time to figure out an encryption software system. You're not really sure how you do key management in the first place. You just click a button on our side and we are going to do triple key encryption to ensure that S3 content is always stored encrypted at rest. Someone gets into that content, somehow it's just going to be a bunch of scrambled zeros and ones. So we also have tools like identity and access management. So important for the media workload, there's a sub-feature inside IAM called simple token service, or the token, simple token machine, right? You check out a time-limited, rights-limited credential to look at a specific piece of content from S3, and then in a minute that thing expires, no one else can use that URL, and you don't have to have all of the big infrastructure for building that authentication mechanism. You just earn it from us as a natural part of the system. Using the token service, that's free. It's just a part of IAM, which is a part of EC2. We're really designing more and more tools to make this easier to use. We really built at the start a set of systems that were API-driven and were code-driven so that the builders and the software developers could get in and access these tools. We've made huge strides. If you haven't been in the management console in a year, it's a different thing. Much easier to use, much deeper detail, easier to add more and more features to configure things. Also happens pretty quick. We have a full console now for CloudFront that includes the ability to configure these distributions, makes it easy for you to build the user interface part of interaction. That doesn't change anything about the APIs. The APIs operate independent of this. If anything, the console sits on top of them. So any of the software that you build that interacts with us stays the same. So to get started with this, I certainly encourage everybody. We have a free tier, so an EC2 instance, a T1 micro for a year doesn't cost anything. 5 gigs of storage in S3, that doesn't cost anything. You can put up a CloudFront distribution, you can have a couple of gigs move out of that, that doesn't cost anything. So really encourage you to fire up an account, throw mom's, some video from your house up to S3, put a CloudFront distribution in it, and watch the video. See how the performance is. Take a look. Take it for a spin. It doesn't cost anything. Try your media processing applications. Take the software that you have. We have a lot of different software applications, stuff from Adobe, stuff from Microsoft, stuff from Sorensen, all sorts of different partners. We have a lot of that listed out on our website. Certainly eager if you have applications to take a look and see if they're already pre-built on Amazon. Most of this stuff is push button and it works. We have a new service called the Marketplace, where you can buy software by the hour or by the licensing model for the provider. Just at a click away, you don't have to do any sort of pre-configuration work on your side. Say, I want one of those, hit play. Adobe FMS, for example, is available by the hour. So you don't have to prepay for some big license. You just try it out, see if it works. See how it is in comparison to the stuff that you're using elsewhere. Really encourage everybody to take the time to do that little bit of experiment. It's a pretty eye-opening experience how straightforward that is, how easy that is to get started. We're also really eager. This is the second time ever anywhere that this presentation has been given. So really eager to hear your feedback. Was it too technical? There was some stuff that was tough. Was it not technical enough? You needed way more code on screen. Happy to hear that feedback. We have a feedback form, but you also have, I think, feedback paper on your chairs. Eager to hear if this is useful or if you wanted different kinds of stuff. That's part of the Amazon goal, is to make sure that we continue to iterate to fit what it is that you need. We're also going to give you some credits for that, so happy to have you take advantage of that as well. Please take the time to thank our sponsors, and thank you guys for taking the time with me.